So finally, in box D here, we've gotten to the concept of slope. And what is slope? Slope is just a number that measures the steepness of a line. So we've been interested in how steep a line has been because that tells us whether somebody's moving faster or slower. Here we're just going to find a way of calculating a number associated with it. And just like with speed, the larger the number of the slope, the steeper the line is going to be. So the first formula that we're going to use in order to calculate slope is this one. Slope equals rise over run. So you probably want to jot that down at the top of that page that you've got there in front of you. Now, what do I mean by rise over run? Rise is a measure of how much the line goes up. Run is a measure of how much it goes across. Okay? So in a distance time graph, run would be the amount of time. Rise would be the amount of distance. So our speed would be distance divided by time, or rise divided by run. So let's look at this first graph here where we've got these 2 points, A and B, and we've got a line drawn between them, solid black line. We want to be able to calculate the slope of this line, and we're going to use this formula, slope equals rise over run. And the easiest way to find the rise and run is to do exactly what they've done here. Draw a horizontal line going across, and then a vertical line going up, okay, to form this nice little right-angled triangle here between your 2 points. The amount that it goes up, or this side of the triangle, is our rise. So how much is our rise here? Well, this thing goes up by, we can just count the boxes. 1, 2, 3, 4, 5. So our rise for this line is 5. How much does this line go across? Well, our run is the length of this line across the bottom. Let's see. Again, we can just count the boxes. 1, 2, 3, 4, 5, 6. So our run is going to be 6. So if we put this together, rise over run is 5 over 6. So for this line, our slope is 5 over 6. Right, let's look at the second one here. They've already drawn the triangle for us. Again, we want to use slope equals rise over run. Rise is how much it goes up. Run is how much it goes over. So what is our rise for this triangle here? Chris, what's our rise? How many? 2 goes up 2 boxes. Good. What is our run? How much does this thing go across here? Nazareth, how many boxes across the bottom? Is it 6? Looks good. Okay. So our slope is going to be rise 2 divided by run 6, or 2 over 6. And when we get a fraction like this, we always check to see if we can put it in lowest terms. We can divide our top and our bottom by 2. So our slope here is going to be 1/3. Okay. Now, if you want, you can turn these things into decimals. 1/3 we know is 0.33, repeated, so on and so on and so on. What do you get when you do 5 divided by 6? Somebody punch that into their calculator for me here. 0.82. Okay. So which slope is bigger? Well, the 0.83 is bigger than the 0.33. And as we would expect, this line from A to B has a steeper slope. Okay. So this has, we'll just change colors here. We'll say larger slope equals a steeper line. Okay. The other thing to notice about our slopes here is that both of these are positive numbers. Okay, we've got positive 0.83, positive 0.33. And both of our lines are going up as we go to the right. So we'll just make another little note in here that a positive slope means the line goes up to the right. Because we're always going from left to right here, just like in those distance time graphs. So bigger number there means steeper slope. Positive slope means line goes up as we go to the right. All right, we got two more examples here that we want to look at. Now, what's different about these two lines as compared to the last two? Our last two went, Chris? Yeah. So these lines go down as you go to the left. Let's see, line goes down from left to right. These ones are going to have negative slopes. Again, we still want to use this formula. Slope is rise over run. So where does this negative come from? Well, let's look at the first line here, EF. Okay. Our run, they've drawn the little triangle for us. Our run is going to be 1, 2, 3, 4. Our run is 5. Okay. Our rise, though, is this distance here. But instead of going up, our line is going down. So it's falling. So our rise is going to be a negative number. It goes down by 1, 2, 3, 4. So our rise is negative 4. So our slope here is going to be negative 4 over 5. Okay. What about our second one here, the line GH? What do we get for our rise and our run in this case? What's our rise here, Jackie? No, sorry. Well, I've labeled this backwards. You guys should be shouting, hey, what are you doing there? Our run is across the bottom. So what's our run, Jackie? Across the bottom. How many? How many boxes? From here to here. 4? 4? Does it look like 4? Does it look like 3? Yeah, it's supposed to be 3, I think. A bit of a bad photocopy. Here's the tricky part. What is the rise here? How much is this thing going up by as we go from left to right? Well, it's not going up. It's going down. So our rise has to be negative. Negative, let's see, 1, 2, 3, 4, 5, negative 6, I think. So our slope over here is going to be rise over run, negative 6 divided by 3, or negative 2. Okay. Now, of these two slopes, which one is the bigger number? Okay. And when we compare these, don't look at the signs, okay, just look at the number. So just look at 4 over 5 and 2. Which of those two numbers is larger? 4 over 5 or 2? What do you think? 2 is bigger. Is this a steeper line? Yeah, this is a much steeper line. GH is steeper than EF. So this makes sense. We've got a bigger slope. We should say a bigger number for the slope equals a steeper line. Let's try writing that word steeper again. Steeper line. Okay. Now, before we leave here, we're going to do one little more thing here. Another little note here on horizontal and vertical lines. So we already looked at these right at the very beginning. We're just going to take another look at them again here. So our first line here, we've got a horizontal line. And it's a little hard to see in your photocopy. We're looking at this line right up here, this one up above. Okay. First off, what is the slope of this line? If this was a distance time graph, what would be the velocity of this line here? 0. Yeah, so our slope here is 0 as well. Okay. Now, they want you to be able to represent these lines with equations. This is where we're going in this unit here. So I'm going to show you how you get the equation of this line. Okay. Imagine picking a bunch of points that are on this line and looking at their coordinates. So if I pick this point right here, this has got coordinates x equals 0 and y equals 2. If I pick this point over here, my x is 2, my y is 2. If I pick this point right here, my x is negative 2, my y is 2. Okay? So if we look at those three ordered pairs there, negative 2, 2, 0, 2, and 2, 2, what is the same in all of those ordered pairs? Andrew, what is the same about those three ordered pairs? They all end in 2. And that second number there represents what? X or y? Yeah. So we've got y is 2, y is 2, y is 2. And any point on this line is going to have a y value of 2, because that's how far it goes up. That's our equation of this line. Y equals 2. Okay. Now, if we've got a vertical line, we can do something similar. Our slope in this case is, we talked about this earlier, our slope is undefined. Okay. But we can come up with an equation for this the same way we did with our horizontal line. So we're looking at this one over here. Okay, let's pick some points that are going to be on this line. Well, if I pick this point right here, it's got an x of negative 3 and a y of 0. If I pick this point right here, I've got an x of negative 3, a y of 2. If I come down here, I've got an x value of negative 3 and a y value of negative 3. All right. What's the same about all of the points that are on this line? Cool? Yeah, we've got an x equals negative 3, an x equals negative 3, an x equals negative 3. So if that's the thing that's true about all of the points on this line, what do you think the equation is going to be? What do you think, Jackie? All of these points have x equals to 3. What's our equation going to be? Nope. Up here, we just had y equals 2, because what was common to all the lines was y was equal to 2. It's just going to be x equals negative 3. Okay. And that's where we're going to stop.